Sir, am I audible to you? Yes, yes.
Yes,
Am I audible, sir? Yes,
yeah,
yes.
yeah.
Respected Rahul sir, vertical head, technical cell, central office, and all the dignitaries and all the participants, very good afternoon to all of you. Today, our speaker is Mr. Yash Shah, who is basically chartered accountant and associated with the SJ Technical Consultant Private Limited. In fact, sir, he's looking after so many projects of large assignments like Tata Projects, Reliance Infrastructure, Hitherto, and SPML Infra Limited, which is the leading wastewater treatment plant. Sir, basically he is from Sri College of Commerce. He has created a history in the chartered accountants and company secretaries courses. He ranked the top position in all over India. So if I enumerate all the degrees and something, that will take, I will be sort of the papers only. So this is all about the our speaker, sir. And today our speaker will cover the introduction part, function, and revenue model, challenge and opportunities for the banks. These topics will be covered by our speaker, sir. So this is just in short, sir, about the speaker. Now I will request you to kindly inaugurate this session by your blessings, sir. Over to you, sir.
Thank you, Rajiv ji from Jula, Gurgaon, and thank you for taking this initiative. And I am really thankful for our panel consultant SGA for taking a pen and going to enrich us in this 1 hour program for especially upon the sewage treatment on various aspects. SJ has been our consultant in many, because I have gone through their TV report many times, and it is a class apart to always have a read the report of SJ. And coincidentally, he is from SRCC. I am also from DU only, so I could correlate, and glad to know that you are the CA topper once upon a time. That is a very good sign for us also. And this team is mainly, we are, whoever is associated in this VC are mainly looking after the TV analysis of the project from the banking perspective. What is the, so I will request to please enlighten us with this sewage treatment plant, because many of us, because right now with the ECG framework, this sewage treatment plant and all these things have gained really momentum. For 5-6 years, even 10 years back, bank was not financing it, and was not considered as a very niche area. But right now, we are also working on 1 or 2 projects about this sewage treatment plant, of very big projects. And this is a way to come, because we are going to a zero discharge thing. So right now, I will not take much time. Right now, over to Mr. Yash Shah and SJ team. So please take us over through this entire journey. Thank you.
Thank you, Rahul ji. Thank you, Rajiv ji, for the lovely introduction. I would like to extend a very warm good evening to the entire house. And I would like to thank the Union Learning Academy for organizing this webinar on this digital platform. And of course, Rajiv ji and Rahul ji have given a brief introduction about me. I'm Yash Shah. I'm part of the leadership team at SJA, which is a 40-year-old industrial and financial consultancy organization on panel with almost all large public sector banks and financial institutions for integrated services starting from appraisal right up till post-disbursement monitoring. So that is about us, in fact. And so we can move on to today's agenda, which is discussion on the sewage treatment plants in India. I'll just share my screen and have our presentation with which we can get started. In fact, I'll just share that window so that you don't see the obstruction. So I hope the presentation is visible to everyone and I am audible.
Yes, sir, you are audible.
Right, sir. So today we have a very interesting topic at hand, which is the sewage treatment plants in India. So before we start, I'll just give you an overview of the agenda that we plan to cover today. So basically, we'll start with an introduction to the sewage treatment plants. What exactly is sewage? What is a sewage treatment plant? And we'll discuss the problem statement. Discussion on the problem statement is very important before we discuss the project, so as to understand from where exactly the need arises for that particular project. Then after that, we'll discuss the entire process because before we discuss anything about the project cost, the components of project cost, the implementation period, it is very important to acquaint ourselves with the entire process of sewage treatment, as also the various technologies which are adopted in India for doing the same. You'll be surprised to know that there are more than 25 different technologies in India for carrying out sewage treatment. Of course, there are about 3 or 4 technologies which are more popular than the others, and we'll throw some light on that. Thereafter, we'll have a discussion on the entire project cost as to how much cost can you expect per MLD. So MLD is the unit which is utilized while discussing about sewage treatment. It is million liters per day. So we'll have a discussion on that. We'll dive into the various components of the project cost, the breakup of this particular project cost. We'll discuss about the total implementation period of the project, as also the major milestones which are achieved whenever one is setting such a plant. We'll discuss about the various statutory approvals which are required pre-establishment, during the course of implementation, as also the post-establishment approvals. We'll have a discussion on the economic outlook, and we'll end with the case study of an actual sewage treatment plant which was carried out in the recent past by our team, and go over the various financial matrices and assumptions which were adopted, which will throw more light into how we can go about appraising such projects. So first of all, a very brief introduction. In fact, what exactly is sewage? Sewage, as we all know, is nothing but wastewater which is generated from residential. That is, a residential house has a toilet, has a kitchen. All these are sources of wastewater. A commercial establishment is also generating waste, like say an office or a hospital or a restaurant. All these are also sources of wastewater or sewage. And of course, industrial establishment, if we take the example of maybe say a tannery in Kanpur, or maybe a dyeing unit or a ready-made garment unit, having the washing section and all, and various other factories, in fact, which are generating sewage on a very large scale. Now, this water contains pollutants, and it's important to understand that there are 2 kinds of pollutants in the water. One is the organic content and one is the inorganic. So when we discuss the process, we'll understand as to which stage the organic pollutants are getting removed and at which stage the inorganic matter is getting removed. Organic, as we all know, is anything which is derived from living things, and an important characteristic is that it contains element of carbon. So these are the common pollutants, that is the organic, the inorganic, pathogens are there, and of course chemicals are also there. So the main sources, as I said, the domestic sources there, the industrial effluents are there, commercial restaurants and offices, and other than that, agricultural runoff. Runoff is nothing but water which may come onto the agricultural land, and rather than seeping into the ground, runs off into some water source. Such runoff may contain elements of fertilizers or pesticides, which again pollute the water and require treatment. The next very fundamental aspect is, what is a sewage treatment plant? It's basically a facility which is designed to treat sewage, to remove contaminants, and making it safe to release into the environment or reuse. So the problem statement starts with, why exactly do we need a sewage treatment plant? First of all, of course, there's the environmental protection aspect. We have statutes like the Water Prevention and Control of Pollution Act 1974, which mandate rules regarding a comprehensive way in which we should go about protecting our water bodies and saving them from pollution. That is one aspect. Second is, of course, public health. If pollutants seep into our water, it is possible they may find themselves into water sources which are utilized by human beings, thus making it a threat for public health. Water scarcity, as you all know, even though our earth is 3/4 water, but only 3% of this water is actually fresh and fit for human consumption. So if we are able to structure a mechanism of recycling our water, we will be able to address this problem of water scarcity as well. And other than that, of course, as I told you, regulatory compliances are there. Of course, when any kind of factory is getting an approval from the Environment or the Pollution Control Board, they definitely mandate, if not a sewage treatment plant, many a times a water treatment plant before any kind of liquid discharge is made from that particular factory. So these were all very fundamental things. Now I'll move to something very interesting, which I said is the problem statement. Like, how big is the sewage treatment problem in India? And these numbers are, of course, taken from a CPCB report, CPCB Central Pollution Control Board. So if you see the extent of the problem, the total sewage generation in India, as per this report, is approximately 72,000 million liters per day. This is the total sewage generation in India. To address the sewage generation, right now we have around 1,400 odd sewage treatment plants with a total installed capacity of 31,000 MLD. So right away you can see that the capacity is only 40 to 45%. Rest of the sewage generation, we don't even have the capacity right now to treat it. Now from installed capacity, we move to operational capacity. Now see, whatever capacity is installed, a portion of it is obviously under construction, and also a portion could not become operational due to various factors. They could not get the requisite approvals, or maybe the Pollution Control Board found that the effluent is not up to the norm, or they went into financial stress. There can be X number of reasons why the capacity did not become operational. So effectively, what we have right now is around 1,000 sewage treatment plants which have a capacity of 26,000 MLD. Now, of course, whatever capacity is created cannot be utilized. So the actual utilization is 20,000. And the problem gets aggravated even further as only 578 sewage treatment plants with a capacity of 12,000 are the ones which are able to comply with the CPCB norms as of now. So CPCB has given certain norms when it comes to the output of the sewage treatment plants. These norms are in terms to, you can say, the pH, the color, the BOD, the COD. BOD is basically biological oxygen demand, and we'll discuss that in detail because that is a very important factor when it comes to sewage treatment plants. Then there is the fecal coliform bacteria content. So all these norms are there, which are defined by the CPCB. And as of now, only 578 plants are able to comply with this norm. So as you can see, the demand supply gap is very big. So the key takeaways from here are that whatever sewage is being generated, only 44% capacity we are having right now to treat. Out of that, 37% is operational, and out of that, 27% is actually being utilized. And as I said, only 16% of the total capacity is actually able to comply with the norms which have been stipulated by our pollution control. This is our overview of what exactly this problem is. Where is the demand supply gap? Now our next discussion over here, which is a very interesting discussion and will form the premise for everything else which we discuss, is the process flow chart. Now it's very important to understand how exactly is sewage being treated. Once we have an understanding of that, we can delve into the technologies which are being adopted in India right now, and then other aspects will bring about more clarity when we know how exactly the sewage treatment is taking place. So I won't go into these slides and all. I basically have two videos over here. One video is basically a diagrammatic presentation. So see, many a times when we go to the plant, we are not able to see a bird's eye view because a lot of things are happening behind the scenes. So that is why I want the house to first see a diagrammatic representation, and then we'll do a short tour of a plant. This is an actual sewage treatment plant, so that we have absolute clarity on what exactly is going inside the plant, which is very important before setting up or even appraising any kind of project. So the 4 stages, I'll just tell you the names and we'll see it. Any sewage treatment plant, it may be adopting any kind of technology, will broadly have these 4 things. First is the primary or the physical treatment, and we'll discuss that in detail. Second is the secondary or biological treatment. Third is the tertiary or chemical treatment. And the fourth aspect is the sludge handling. So I'll just right away open this particular video. And I'll just take you through all the steps which come over here. So of course, the story starts with all these establishments, creating sewage. You have houses, you have offices, factories, and these are the sewage lines. This is an overview of the entire plant, and we'll go one by one on each aspect. These are all the systems and pumping systems which are there in the particular plant, and we'll go one by one. So this is just a bird's eye view of, from start till the clarified water coming out and this going into the sludge processing. So the entire story starts with sewage moving into the plant. The very first chamber that you will find in the plant is a bar screen. So these are basically big screens, mesh-like structures through which the water is made to flow. The objective of the bar screen, as you'll see, the big matter, it has all these vertical bars installed and all the big matter which is there, because see, sewage contains all sorts of things, plastics, cans, debris, bricks, any possible thing which you can think of. So over here, those things get segregated out. And after that, it moves into a particular tank, which is called the grit tank. Now, as the name suggests, this particular tank basically removes all the grit, which is the sand, the rocks, the stones, the mud. It all gets settled down at the bottom. After this, the water moves into something which is called the primary clarifier. Of course, they've used the name settling tank, but the more popular name in the industry is a primary clarifier. Primary clarifier serves two purposes. It is primarily purifying the water by way of sedimentation. So the water is allowed to stay here for good 4 to 8 hours, 4 to 7 hours, during which the heavy matter, settles down at the bottom, and it's called sludge. And of course, the water also contains lighter density impurities like oil, grease, all those things which are lighter in nature, and they rise to the top. So when you see the video, the actual video of the plant, you'll see there's a moving arm moving about this clarifier, which skims off all this scum which gathers at the top. So I'll just show you that this is the heavy particle in the clarifier, which is called sludge. And this part is called the scum. And in center, you have what is the clarified water. This is the primary function of the primary clarifier. So all these three things, which is the bar screen, the grit tank, and the primary clarification, form the primary treatment or the physical treatment. As you can see, everything is very physical in nature. There is no biological process involved here. There is no chemical being used. It's entirely physical. So this stage of the plant is what is called the primary or the physical treatment. Now from here, the water moves into the heart of the sewage treatment plant, which is the aeration tank. Aeration tank is basically the heart of any sewage treatment plant. Over here, what happens is that there's a biological process. So I'll just give you an oversight as to what happens. So as I said, this water contains a lot of organic impurities. Now, the measure of organic impurities is BOD, biological oxygen demand. This is the measure. So like if I give you more insight, BOD, if you take a sample of sewage water, the amount of oxygen that sample will consume over a duration of time is BOD. Now, the higher the organic impurity, the higher the amount of oxygen the water will consume. When I say water, I mean the bacteria in the water. What they do is that they consume oxygen and they decompose or digest all these organic impurities. So the purpose of the aeration tank, and we have the lab taking sample of the BOD from here and the BOD from here. So the CPCB norm for BOD is approximately in the range of 10 to 11 mg per DL. That is what they strive to achieve. 10 mg per liter, not DL, sorry, 10 milligrams per liter. So over here, what happens is that there is aeration done in this chamber. You have air compressors throwing in air, and meanwhile the bacteria, they utilize this air to decompose or digest all the organic impurities. That is what typically happens in this particular section of the plant, which is the heart of the plant. And this is what we call the secondary treatment or the biological treatment. Thereafter, it moves into the secondary clarifier, which is very much similar to the primary clarifier. Now, right now, the sludge which settles down is activated sludge because it contains huge colonies of bacteria. We have allowed bacteria to reproduce, we have given them food, and they have multiplied in great numbers now. And that is why this sludge is called activated sludge. It contains a large amount of these bacteria which settle down at the bottom and sometimes even at the top. So both these places, this kind of extraction is done. Now over here, our biological treatment is completed. And so this particular part of the plant is our sludge processing. So whatever sludge is being generated either from the primary clarifier or the secondary clarifier is subjected to an anaerobic process. Anaerobic means in the absence of oxygen, it is subjected to that process, and anaerobic bacteria act on this sludge, generating biogas in the process, which can even be commercially exploited. And whatever is left behind goes to the sand drying bed. The primary purpose being removing more and more water from this by way of evaporation, so that what is left behind is the compost and can be transported for use as the fertilizer. So this is how sludge is being treated. Whatever waste product is coming out, that is the sludge, and this is how they are managing it. Now the last stage in the water purification is the disinfection, wherein they will go ahead and add chlorine to kill all the bacteria, kill all the pathogens. And in high quality plants, you may even have a UV treatment taking place here, or even a reverse osmosis. Reverse osmosis is a very expensive technology, but if it is done, then the water which comes out is absolutely fit for human consumption. So that varies from plant to plant, what kind of tertiary or chemical treatment you are doing over there. So this is what happens in this particular section, which is the tertiary treatment. And finally, when this is over, the water is ready for discharge into wherever you want to give the output. So this was a broad overview of what exactly the plant is like. Now I think we are ready to do a tour of an actual plant, which I'll just play for you. And I'll just put this little bit on fast forward. And we'll see all these things. Now that you have a background as to what is happening, all this will be very clear. So this you can see, these are all the clarifiers. They are the biggest things in the plant. This is a bird's eye view of the entire plant which is there. This is the town which is generating all the sewage which will get transported to our plant. These are all primary and secondary clarifiers which you see over here. Now see, the process starts with us flushing all this thing down the toilet and the sewage getting accumulated in the drains. This is the first step which I told you about. This is the bar screen where these big cloth impurities, diapers, all these things which people tend to flush down the toilet will get segregated. This is also good for the plant because plant is not designed to handle all these things. So it gets removed at the very first stage. This is what is coming out of the bar screen. You can see the kind of waste. Next, as I discussed, is the grit chamber. Over here, all the grit will get settled down at the bottom. Aeration is being constantly done to facilitate that process. And you have all the grit, sand, everything coming and settling down at the bottom. This is again a view of that bar screen only, doing the physical segregation. This is the grit chamber. From here, we will move to the primary clarifier. This is the primary clarifier. This is exactly how it looks like. If you go to a plant, you will see this. These are huge, big structures. They need a lot of land area, and I will discuss the consequence of that also. This is the skimming which is taking place at the top. Whatever I told you, the light impurities which float up to the top, this is how the skimming takes place. And whatever heavy particles are there, they get settled down at the bottom. And from between, the clarified water is taken to the next step. You see how this skimming took place over there. So this arm keeps moving for good 5 hours, 6 hours. Sedimentation takes place, and the primary clarification is completed. Now, the next part of this plant I will skip because that is not something very relevant to India. This technology is not there. In our case, it moves straight from the primary clarifier. You can ignore this part. This you will not see in any plant in India. It moves directly to the aeration basin. These are the aeration basins, which I said is the heart of the plant. The air is released into the basin. The bacteria, they consume this air. and then they decompose, digest all the organic matter. Consequence is that the BOD, which the input water is having of about 150 mg per DL, has to be reduced right down to 10 mg per liter, and that is as per the CPCB norms. This is the tank which plays the primary role. Then, of course, secondary clarifier comes into the picture. The same thing as primary clarifier. Of course, over here, the sludge is highly activated in nature because huge volumes of bacterial bodies have formed, which need to be removed from the water. Now that they have done their job was primarily to decompose. This is again an overview of the entire thing. And after this is the tertiary treatment. As I told you, chlorination will be done to kill all the microorganisms. This is very similar to the AquaGuard which we have in our house. MCD is doing the chlorination, and then we do the UV and the reverse osmosis and all. So that was finally treated water which you saw. This is another important part of the plant, which is the digester. All the sludge which is coming in is getting treated anaerobically. Biogas will get generated in this process when anaerobic respiration and anaerobic bacteria come into the picture. Anaerobic bacteria are highly more effective than aerobic bacteria. They in fact even feed on the aerobic bacteria. And ultimately the output which will come out, you will need to extract all the water from that output. In India, of course, it is done through sand beds. You will see the belt press being utilized here primarily to remove the water. And ultimately, this thing will get converted into compost for usage as fertilizer or for further disposal into a sand pit. That is how typically the entire process works. This is the final compost and all which is getting generated. See this one, this is the compost. So I think now we have a very good idea about how exactly things work in a sewage treatment plant. Primary physical treatment is there, secondary biological treatment is there, tertiary chemical treatment is there, and sludge handling. Now, any technology you pick up, it will ultimately have these 4 activities being performed in different ways. So we'll discuss that. Now, these are the 3 very popular technologies which are used in India. 26% of plants in India are deploying the activated sludge process, ASP. I'll just put this on full screen. So activated sludge process, 26% plants are using. 29% are using the sequential batch reactor, which is also a very popular technology. And 6% are using the MBBR or the MBR, which is a very good technology in terms to quality. But then, as you will see, it is highly costly and complicated to manage. O&M cost increases, and I'll tell you why. So this process is basically a continuous flow, which you just saw. The plant you saw was basically an ASP-based plant. You saw that the aeration, the primary clarifier and secondary clarifier, which are the sedimentation sections, are separate. Now, the consequence of them being separate is that they require a lot of land area. So in areas where land is a constraint, ASP will not be successful. Then you have SBR. SBR kya karta hai? SBR basically does not have separate tanks for aeration and sedimentation. They just have one sequential batch reactor. Now, as you can see from the name, it's a batch process. So from the grid chamber, there is no primary clarifier. Water will go straight into the batch reactor. Batch reactor will run one batch of 4 to 5 hours. Sedimentation will take place. Then it will skim away. After that, in this very same tank, they will pump in air and they will do aeration for 4 or 5 hours. Then when aeration is done, in the very same tank, they will do sedimentation again. So you saw that a single tank was utilized for all these 3 activities in a batch manner. So this greatly reduces the land requirement and makes it a very efficient choice. That is why you see that 29% plants have utilized this. MBBR, what it does, MBBR also does not have the two clarifiers, and it does not have the aeration tank. In fact, it has the aeration tank. It's called by a different name. It's called an MBBR tank. Now, in MBBR tank, what happens is that there is a medium which is inserted. This medium contains chemicals which not only provide air to the bacteria, they also provide food to the bacteria, and they provide other nutrients which help the bacteria to thrive. And throughout, this medium is circulated inside the water. Now, what this results in is that the decomposition is much more efficient because you are giving, number 1, food to the bacteria. Number 2, what you are doing is that you are moving the bacteria all over the water and improving the decomposition process. That is what MBBR is. So 2 MBBR tanks are there, and instead of a secondary clarifier, there's a lamella clarifier. Lamella clarifier has sheets. So the clarification process, it's ultimately a gravity-based sedimentation process, but because these sheets are installed, the clarification process is much better and much more efficient. Now, as I said, land requirement for ASP is the highest. Sequential batch reactor is the lowest because there is only one batch reactor. There is no clarifier. There is no lamella clarifier, anything. This has a medium kind of land requirement. Output quality. See, this one output means the output water which is coming. This is of a moderate quality. And these two are of a very high quality. MBBR especially, and MBR, which is another modification of MBBR, which has a molecular sieve also, like a reverse osmosis film. It's of a very high quality. And in fact, in many cases, it can even generate drinking water. But the problem with MBBR and MBR is primarily that they are very costly. So if you see the cost, the cost for ASP is the lowest, and we'll discuss exactly how many crores per MLD is this working out. But right now, I'll tell you this is the lowest. SBR is slightly higher, and technologies like MBBR and MBR are the highest, not only in terms to the initial capex, but also in terms to the O&M, because this media I told you about and these membranes I told you about, they need to be replaced from time to time. So that significantly increases the O&M cost. Sludge production ASP is highest, SBR is moderate, MBBR is moderate. Energy consumption is low to moderate. SBR and MBBR is moderate. The MBR, which is Ford technology, it has the highest energy consumption because you need to pump water through those molecular sieves. That requires more energy. Now coming to the pros and cons, as I said, ASP is one of the oldest and well-established cost-effective ways of sewage treatment. However, the con is that it requires a high land requirement and sludge generation is also high, and the quality of water is not that good. Quality of the treated water is not as good as compared to say an MBR or an MBBR. Sequential batch reactor is high quality water, smaller footprint in terms to land, but it is complex. See, now you are doing everything in one tank. So it is complicated. You have to manage. Someone has to manage, 5 hours, one batch, then second batch. You can't have any mixing of batches. Otherwise, it will spoil the entire thing. So it is complex. And of course, cost is high. MBBR is high quality effluent, smaller footprint, but cost and maintenance, as I told you, is high. So these are the three popular technologies. And of course, other than this, there are about 24 more technologies. I just discussed the top three, which typically, come to lenders in terms to the project reports and all. ISP is very common. SBR is very, very common. So that's about technologies. Now let's come to the all important part of cost. Now coming to the total project cost, it can range anywhere between 1 crore to 4.5 to 5 crores per MLD. Now you will obviously see that this is a very wide range. Typically, in projects, you do have standardized range. Like if I give you an example, for a grain-based ethanol plant today, if you want to establish, the cost will be somewhere between, 1.25, 1.5 crores per KLPD. It's a very short 50,000 range. But over here, the range is very wide because there are so many different technologies. So if you set up an ASP plant, you can get a costing of somewhere around 1.25, 1.5, 2 crores per MLD. If you go into a sequential batch reactor, SBR kind of plant, that can, depending upon the other things like what kind of area is there, what kind of logistics are there to get the sewage to the plant, it can range anywhere from, maybe 2.5, 2.75, 3. I've seen SBR plants go up till 3.5 crores per MLD also. MBBR and MBR are very expensive technologies. That is why they have not been very successful in India. Their costing may range somewhere in the range of 4 crores, 4.5 crores. And if you use some advanced kind of MBR because these sieves, are of different makes, then it will even be higher. So it depends on the technology and location, but a broad range in which the project cost is there is this. Out of that, land development and civil works are somewhere to the tune of 30 to 35%. Because all these chambers, the primary, secondary, tertiary treatment chambers are all civil work. The sludge handling unit has civil components. Mechanical work, which is our plant and machinery, the other fixed assets, all those things is 40 to 45%, includes the aeration system, screening system, pump, clarifier, instrumentation and control systems. All these things are there. Then, of course, installation and commissioning is another 5 to 10%, which includes integration, alignment, testing, trial, commissioning, all those things. Whatever is left behind is, of course, a part of the soft cost. These, what I discussed, are the hard cost. So that's about the project cost as regards the sewage treatment plant. Now, The next important thing that we have to discuss is the implementation period. Now, typically, you would have a sewage treatment plant getting, commissioned in 1.5 to 2 years. This may also get delayed because, a large part of the lining with the gel board and all, and in terms to the availability of land, connectivity of the incoming sewage, connectivity of the output effluent, these things tend to delay the process, which are many a times, not in the control of the person who's installing the project. But anyhow, an average which you take is 1.5 to 2 years, which may increase depending upon the facts and circumstances. The main milestones over here are, of course, first of all, we have to do the project planning and the feasibility study. We'll do the site survey, we'll do the feasibility study. If financing is involved, we'll tie up the financing arrangements, we'll achieve financial closure, and we'll secure the necessary permits and approvals, pre-construction permits, which of course we'll discuss in a later slide, what exactly are the statutory approvals that you require for setting up such a plant. Then you will do the procurement, the tendering and selection of contractors and suppliers. And of course, there are many reputed contractors for various technologies which are already well known. So they are there. Then site preparation and civil works, you can do the clearing of the site, constructing of the civil structures and laying of the pipelines. The entire civil structure will come into place. The various basins and the tanks will get constructed. Once all that in place, you can go ahead with your installation of equipment. You can install your aeration equipment. This plant is having high amount of pumping equipment also involved, to pump water from one tank to another. Different, very commercial, powerful kind of pumping machinery is required. And the electricity cost, once you see the commercials, you'll see that electricity cost also constitutes a very big portion of the O&M. A lot of electricity is consumed by all these equipments. And the control systems, many plants, which are advanced, are having the centralized control room to monitor each and everything which is happening in the plant. Then you will proceed with your commissioning and testing. You'll conduct your trial runs, you'll do the performance testing, you'll calibrate your systems. Then after that, there'll be operational readiness and handover, wherein you will train your staff, you'll do the final inspection, and you'll hand over to the operating authority. This is about the operational readiness and handover. Then, of course, once your plant is there, it will require some time to come into alignment. You will do the monitoring and you'll maintain the plant during the initial operational period. So all this will typically take 1.5 to 2 years till the post-commissioning monitoring. And so that's about it regarding the implementation period. Coming to the statutory approvals which are required, excuse me, I'll take some water. Coming to the statutory approvals which are required, first of all, of course, you need a temporary power connection during your construction phase. Then you will have the electrical load approval from the State Electricity Board. That is very important because I told you it's a very power intensive kind of operation which is there. Then the standard consent to establish, consent to operate from the State Pollution Control Board is applicable here also. There is a consent for storage of hazardous material. Now, sewage is a highly hazardous material, so you will need to get this consent from the Director of Explosives. You will need to apply for the NOC and approval from the local gel board because you will be handling water for which they are absolutely responsible. Then there is the layout and plan approval to be done by the urban body and the Directorate of Town Planning. You will need to get your building plans approved in advance. After that, if there is any kind of tree cutting, road cutting, railway crossing involved, the Forest Department, PWD and railway authorities will give the requisite approval. Factory license is very important under the Factories Act and the relevant factory rules which are there. Labor licenses, of course, in a post-commissioning stage need to be obtained. During the construction phase, there is the contract labor license which needs to be available, which is typically done by the EPC contractor. Then you need approval of the Chief Electrical Inspector. Again, as I said, it's a very electricity intensive operation. This approval is also required. Fire clearance is there, and there is NOC from the urban local body for sewage. So these are all the statutory approvals are there, which can be bifurcated, into pre-construction, like temporary power is a pre-construction approval. Load approval will be somewhere typically post-construction. Consent to establish will take pre-construction. Consent to operate you will do when your plant is ready. This particular you can take, right when you are approaching the commissioning. This kind of approval can be taken once you start handling the sewage. NOC upfront, of course, NOC is required, and at the time of completion is also there. layout plan approval is required initially when you draw up the plans, and once your construction is complete, sort of a completion certificate thing is also there. And so this is how the statutory approvals are structured. Now, over here, we actually have a financial model which was structured for one of the sewage treatment plants. These are some of the key matrices which are there. So it was a 47.7 MLD plant which was set up in Uttar Pradesh. And the cost was, of course, working out to 3.75 crores per MLD. It was based on SBR technology. Cost was little bit on the higher side, but this is what it was. I think there were some inlet and all which needed to be constructed, which was also adding to the cost of this particular project. The implementation period envisaged was of 2 years, followed by 15 years of O&M, for which they had an O&M agency, in fact, carrying out the entire thing. The means of finance which was structured was 38% debt, 16% equity, and the state government also came up with a 45% grant, because of course this plant would ultimately meet one of the objectives of the state government. So they also pitched in with a 45% grant. Average DSCR 1.78, which is fine, fairly comfortable. Minimum DSCR of 1.58, which is again above the threshold, and IRR was 13.19%. That is what the matrices were working out to in terms to the financial model. I think since we do have time, I can even open up the Excel and maybe we can peruse the model firsthand. I'll just do that. So this is what the modeling was like. So as you can see, the total project is 47.7 MLD in the state of Uttar Pradesh. And you have these project timelines which are there. Overall implementation period is around 2 years, which is there. And they are expecting to achieve COD 1st April 2024. And operation was 15 years. Of course, this was an award which was done by the Jal Board of the state. They had given a concession period of 17 years, 2 years construction and 15 years of O&M. And during this period, they were the ones who were giving the annuity to this particular project, which was the primary revenue stream over here. This is the breakup of the project cost. As you can see, they have appointed a back-to-back EPC contractor, which also may have increased the cost, that they did not implement it themselves. They had a back-to-back EPC in place. And pre-operative expenses are there. Some IDC and all is also there. Total project cost is approximately this much. Then we have done the phasing of the project cost over various years. This is how typically it is done. So you can see 46% of the cost was expended in the first year, and 53% of the cost was expended in the second year. And other than that, these are normal workings, phasing of cost, phasing of means of finance. Means of finance, as I told you, 31 was contributed by the promoter, 31 crores. In percentage terms, it will work out to what I told you. Grant was there, and the debt component was also there. Then debt schedule, other schedules, DSCR, IRR, as we discussed, minimum DSCR of 1.5, which is above the threshold of 1.25, and average DSCR of 1.78 is there. Project IRR is working to 13.19%, and ultimately the financials and all, this is how they were drawn up. So this was a review of an actual plant which was set up and financed by the Indian banking system. I'll go back to my presentation. Okay, it's sharing the screen only. So let's talk about the way ahead and conclusion. So as you could very well see, there's a significant capacity shortfall in India when it comes to sewage generation. We only have capacity to installed capacity to meet 44% of the sewage generation. Actual utilization is 75% of this. So there is a capacity shortfall. There is a problem statement. Infrastructure improvement, we need to strengthen the sewage conveyance systems, including household connections and sewer lines. This is actually one of the very important reasons why the capacity utilization is low, because the sewage is not connected. Ultimately, plant can only work when sewage reaches the plant. If there is no means for the sewage to reach the plant, then of course capacity utilization will be low. Compliance and quality focus needs to be there, as only 23% of the treatment capacity meets the regulatory standards. In fact, if you go to the website of the CPCB, you can see on a real time the compliance status of all these 1500, 2000 plants, which I told you about, because CPCB does carry out quality checks and sends notices to these plants when they are not able to meet with the requirements. And then the plants have to give them an action taken report as to how they plan to align themselves to that. So of course, there is a need for improved O&M so that this percentage can go up. There's a diverse technology that I told you. STPs use various technologies. SBR is one of the most common because it uses less land. That is one of the primary reasons. ASP is also very popular because, see, many areas land is not that big a constraint. Cost may be a constraint. And ASP is a very well-established technology. You don't need a very expert O&M team to run the ASP. It will typically run on its own. There is no batch processing. There is no changing of the molecular sieve. There is no adding of the media like other technologies. There are, of course, regional disparities. Major treatment facilities are concentrated in 5 states. Regions like Arunachal Pradesh, they lack sewage treatment plants. And of course, government policy needs to be directed towards utilization of treated sewage. If government can make certain processes mandatory, that this process will only run on treated water, then of course this process will create a demand for sewage treatment, in turn utilizing all this excess sewage which is presently being generated and going into all our rivers without any kind of treatment. So with that, I come to the end of my presentation, and I would request all the esteemed team members, as we would love to gather your feedback on today's session so that in future we can make these sessions even better. I've added a QR code which you can scan to give feedback on this session. And to motivate everyone for this feedback, there's a special bonus which I'll be sending across in relation to today's session to everyone who captures this particular feedback. So we can take a minute, we can scan this QR code. I can give you the link also on the chat window. It's a very small feedback form which allows us to understand how successful the session was, and gather view from the participants as to what other things could have been incorporated to make this even better. Just take 2 minutes here. And I'm even sending this on the chat. This is the feedback form link. So you can either take it from the chat or you can scan it. These days everything is better with QR. So I put up a QR code in there. And of course, as I said, there is bonus content which I'll be sending across, very useful. So bonus content is basically a comprehensive study which was done by CPCB. You'll get everything over there as to what is the situation of the STPs in our country right now, what kind of STPs, state-wise position. They have done a very comprehensive study that I'll share with you. And maybe even this presentation, if it's useful, I'll send this across as well. We'll just wait for 1 more minute and then we'll move on. Right, so I hope most of you got that feedback, and with that we come to the end of our webinar. And I thank you all for sparing your valuable time for participating today. If you liked the content today, we do regularly post very often, maybe once a week at least, on our YouTube channel. We post a lot of content relating to industry outlook, videos like maybe 7 traits of a shell corporation, videos on credit monitoring, videos on restructuring, videos on valuation of complex assets. And if all these topics are of interest to you, I would urge you to join our YouTube channel, wherein you'll get similar content. And that's about it from my side. We can maybe open the house for feedback or Q&A and other things.
Hello.
Anyone can put your queries. If any queries, please.
You can send it to us by mail also. I have shared my mail ID. In case anything remains, please feel free to drop us a mail. We are very prompt when it comes to answering mails.
Good evening, Yash Shah, sir. Am I audible?
Yes, sir, I can hear you, but I can't see you.
Sir, I'm in the window, but that window may not be in the front.
Is this Mr. Prateek Jain?
Yes, sir.
Good evening, Prateek ji. Please tell me.
Good evening, Jesse. Yes, your session was very much interactive. I really thankful to you for sharing your views and a lot of inputs you have enlightened about this topic. And it is really an energetic session. I'm having 2-3 points for my understanding, which I just want to ask and want to have the better understanding about
Right,
the topic.
sir. Right.
Firstly, as you have told that this is the revenue model is majorly on annuity based.
Yes.
In this type of product. So whether this type of financing is done under bot or
So your voice is breaking little bit. Your voice is breaking little bit.
1 second, sir. I will do this thing for my voice.
No.
Am I audible, sir?
Yes, it is better now, sir. It is better now, Prateek ji.
Okay.
So I think you were discussing something about
sir,
revenue
I'm having
models.
2-3 points.
Okay.
First thing that as you have told that there is a lot of biogas is also getting produced in the process.
Yes.
So whether that biogas is also being utilized towards the electricity production, which can be utilized for pumping of the plants, and that can be the part of the costing model, which will reduce the costing. Is it happening, or it is being just given for the otherwise industrial purpose that biogas is being used? One point is that. And another point is that since it involves a lot of debris and all, so there may be certain circumstances when the plant may get stuck. It may happen because of the practical or natural issues. So what type of measures these plants are getting in those situations? Because since the supply of the water, sewage water will be on the regular basis. To stop that supply again, it will be it may be a problem as per my understanding. So how they are taking care of that things in case of exigencies, if they have to stop a plant in between the work, and backup planning they are also making, or whether they can stop the plant in between of the process and it will not impact otherwise. And biogas I have already told. And there is another issue. Sometimes I have seen in Panvel in Mumbai, there are few plants which is just near to the residential societies.
Okay.
These water treatment plants. So whether the outcome of those water treatment plants, whether they are creating a problem for the local residents or nearby people, because there may be, because I have not resided there, but I may feel that maybe some smell sort of thing or some other problem local residents may face. So is it so, or it is okay, and that type of thing is not there? And regarding that financial model, that is it purely on HAM basis or any other model is also there? So these are the few queries, sir.
Right, sir. So I'll take these one by one, and then I think a few queries have come in the chat. Although I'll try my best to answer all the queries, but still, if something is left, I'll maybe, because everything there's actually a very big team which is involved from our end when we are structuring this. So I would want to give a very good reply which meets your requirement. In that case, we'll compile these queries and we'll discuss it and give you a good reply, in fact, which attends all the things. Coming to the first point, which is the biogas. So biogas generation is there, but that is majorly dependent on the kind of infrastructure that you are putting in place for your sludge handling. If you have invested well in your sludge handling, you have put in a proper digester, and you are actually, because most of the plants in India, their focus is only on the sewage treatment. Whatever sludge is coming out, instead of putting it into the anaerobic digestion, they are straight away taking it to the landfill. So if you do not put in that requisite capex over there, because the plant I showed you was of Spain. This plant was not an Indian plant, it was a Spanish plant wherein you saw that entire digester being there. But yes, wherever the digester system is there and capex has been incurred on actually recovery of that particular biogas, it is being commercially utilized towards generation of electricity also. That is one thing. Coming to the second part, which is the debris. So as you can see, whatever technology may be adopted, whether it is ASP, whether it is SBR, whether it is MBR, whether it is MBBR, all these technologies will have the primary treatment or the physical treatment, which is very important. And the primary job of placing the primary treatment right up front with the bar screen and the grid chamber. In fact, some plants after the grid chamber, they also have a settling tank. So what happens is that through these three processes, they keep all these substances which can clog up the very expensive, as you rightly pointed out, that if some kind of clogging takes place anywhere, it can be a very expensive affair. So the physical treatment takes place upfront, which removes all this, people have a tendency of throwing all sorts of things into the sewage, debris, even carcass is there when it gets separated, and big plastic bottles, small plastic bottles. So an endeavor is always there on the plant's part to get all these things segregated right up front. And thereafter, water goes into the settling tank. Once they see that the system is stable, it's in a settling tank. It's in a holding area, so that aage jo flow ja raha hai to the primary clarifier, it is in an even manner. The flow is not uneven. That is number one. Number two, as part of O&M, every plant is basically undertaking periodic maintenance, wherein every 15 days, 30 days, they take out some time, they shut down the plant, they do their periodic, because the bar screens require very regular cleaning. There are two kinds of bar screens, which I have personally seen in plants. One is a manual bar screen, wherein a person actually manually, scrapes out all these things. And second is the mechanical bar screen, which you also saw in the video, where mechanically all this stuff is segregated. But again, all these things come at a cost, and it depends on how the project is structured. Thirdly, every year, at least in India, wherever the model is there, they do set out a certain percentage. To my understanding, 5 to 7.5% for major maintenance is there. Which is typically utilized towards maintenance of the plant in every 3 to 4 years. So that ensures, that breakdowns are less. And of course, that being said, you yourself saw that the plants are functioning at 75% capacity. So of course, little bit of disconnect is there, which results in the lower capacity utilization. Coming to the third point, which you raised of residential societies, see, that is a very common problem. Ultimately, industrial areas are to be segregated from the residential areas. Even if it is not a sewage treatment plant, I say it's a sheet metal unit, or it's an auto ancillary, it's a wire drawing plant, it's a cement plant. Any kind of industrial establishment which is established close to a residential area will always cause problem. Now see, it's sewage being treated, compost is being created, biogas is being created. Obviously, there will be a stench will be coming out from the plant, and there is no stench management system. No one has invested in any kind of air purification system. Everyone is focused so much on water purification that air ka to pollution agar kuch ho raha hai is process mein, pollution to kya, smell aayegi usme se. So of course, if it is established close to the, and these are things which are to be factored at the appraisal stage. When we are doing the appraisal, suitability and the locational advantage is a very big thing which needs to be seen before such plants are given approval. Because agar plant lag gaya, uske baad RWA वालों ने complaint कर दिया या society वालों ने complaint कर दिया, आजकल तो क्या आप हाई कोर्ट चले जाओ, थोड़ा बहुत दिखा दो, आपको वैसे ही स्टे ऑर्डर मिल जाता है. तो ये सारी चीजें अवॉइड करने के लिए the selection of the location is very important, and I don't think it should be located close to residential area under any circumstance. Coming to the financial model, see, ultimately sewage treatment, to our understanding, primarily the tenders are given out by the water authority of the state. In some cases, the state government, other bodies are coming into the picture, but it is primarily the water authority. Like Kerala Water Authority is giving out tenders. Delhi Jal Board, like I mentioned, SPML Infra, all of SPML's contracts are with Delhi Jal Board in Delhi. That is how they are working. Then in other states, they are given out by the Public Health and Engineering Department. It's called PHED. PHED Rajasthan, PHED Madhya Pradesh, PHED Uttar Pradesh. These are the bodies which are giving out these kinds of tenders. The tendering is primarily on an annuity basis. As you saw, this particular plant was there. They're also on EPC basis, wherein they engage an EPC contractor, and thereafter they will even engaging for O&M for another 10 to 15 years. So the revenue stream in such plants is number one, the annuity. Number two is payment of the RA bills, which the EPC contractor is raising on a milestone basis. And once COD is achieved, after that, of course, O&M bills are there, which are being raised and they are being paid. So primarily payment is done by the government. That is from where the major revenue is coming through all these channels.
This revenue is budgetary support or otherwise?
Sir, that may be an internal allocation of the government. I'll have to get back to you on that as to from where they are allocating this particular fund. But of course, yes, it's in a way originating from the public money. I would request you to share your mail ID. In fact, if you can send it on the chat, I'll take it down. And on all these 4 points, I'll send you more detailed insights once I discuss this.
Sure, sir. Sure, sir.
I think Mr. Kaustubh Nath has posted a query, which I believe I've answered. He sent a thumbs up on that.
Yes, sir.
So there is a question in the Q&A segment also.
Regarding the revenue options available for such plants.
Revenue avenues are the same thing. In fact, when it goes into annuity model, it's on EPC model. Okay, Kaustubh is also send his email ID. So EPC bills are being paid as the contractor, and once commissioning is there, O&M is being charged. O&M is being done. O&M rates I can share with you. Those are available with us. How much is being charged for maintaining an SBR plant? So all these things which will help us to vet the cost in a better manner, so that the projects which are being financed by us, the cost is rationalized at the very early stage.
Another query from the participants is there.
Right, sir.
What is the best practices globally adopted for this STP plant, sir? Out of all the processes, which is more prevalent.
Sir, I would, if you ask me personally, what I have seen, developed countries are typically a lot into MBR and MBBR. MBR because अब MBR में क्या होता है? MBR में ASP आपने देखा. ASP में there is a primary clarifier, there is an aeration tank, and there is a secondary clarifier. MBR में क्या होता है? There is no primary clarifier. There are 2 MBBR tanks. 2 MBBR tanks are there. MBBR तो खैर मैंने डिस्कस करा आपके साथ कि एक मीडिया होता है, उसके अंदर मीडिया में जो है केमिकल और ऐसे कंपाउंड्स होते हैं जो उस एरेशन को बहुत अच्छे से एक्सिलरेट कर देते हैं. रादर देन कि आप वेट करो कि बैक्टीरिया ऑक्सीजन खींचेगा और डिकम्पोजिशन करेगा, यू आर इंस्टेड इंट्रोड्यूसिंग अ मीडिया एंड देन यू आर सर्कुलेटिंग दैट मीडिया थ्रू आउट. तो उससे जो क्वालिटी ऑफ आउटपुट निकलता है इससे इज ऑफ अ मच हायर क्वालिटी. बट आपका जो खर्चा आएगा इन टर्म्स टू प्रोक्योरिंग दैट मीडिया, in terms to O&M of that media, that will be higher. Then instead of a secondary clarifier, you have a lamella clarifier. Lamella clarifier is much superior, but उसमें जो fins लगे हुए हैं उसको आपको cleaning करना पड़ेगा, maintenance ज़्यादा लगेगी, cost will be more. Now let me talk about one of the best technologies जिसका मैंने discussion नहीं करा, that is MBR. MBBR का छोटा MBR. MBR में क्या होता है? एक molecular sieve लगा होता है. So you don't have either of the clarifiers, you just have one tank. In that tank, aeration takes place. At the time of output, there is a molecular wall which is given at the exit. This molecular wall functions like a reverse osmosis system in the secondary treatment itself. Otherwise, reverse osmosis is tertiary treatment. अब यहाँ से जो पानी निकल रहा है वही अगर सिर्फ से होके निकल रहा है तो बहुत हाई क्वालिटी ऑफ वाटर आपको साइड मिलेगा. बट अब चैलेंजेस क्या है? ये जो आप सिर्फ लगा रहे हो ये बहुत जल्दी का उसकी एक लाइफ है. So you'll have to change it again and again. You'll require a more powerful pumping system to pump the water through that sieve. That is why these technologies are not preferred in India. In India, the most common technology is SBR, क्योंकि cost भी बहुत ज़्यादा नहीं है, space requirement भी बहुत ज़्यादा नहीं है, और मतलब थोड़ा जुगाड़ू टाइप है. इंडिया में थोड़ा जुगाड़ का कॉन्सेप्ट चलता है कि उसी टैंक के अंदर हमने एक बैच में सेडिमेंटेशन कर दिया, उसी बैच के अंदर उसी टैंक के अंदर हमने एरेशन भी कर दिया. एरेशन करने के बाद हमने उसी टैंक के अंदर फिर सेडिमेंटेशन करके उसको आगे छोड़ दिया. So SBR, 29% of the plants, as I said, are deploying SBR. 26% are deploying ASP. 5 to 6% are on MBBR. ये सारे MBBR और ये वाले प्लांट्स तब लगते हैं जब आपको आउटपुट में ड्रिंकिंग वाटर चाहिए. जब आपको आउटपुट में ड्रिंकिंग वाटर नहीं चाहिए, आपको केवल टॉयलेट में रिसर्कुलेट करना है, या यू हैव टू यूज इट फॉर इरिगेशन, या you just have to clarify it before you release into the Ganga or Yamuna, then these technologies are very good.
Thank you, sir. Really, you have answered each and every queries, and really this shows how involved you are. So, sir, I'm very grateful to you. And side by side, I was saying that my Gurudev, I can say BD Shah sir is also listening to you. So really, first of all, I welcome BD Shah sir, and hope he will give the blessing to the entire system and all the things. So you have done exceedingly well, sir, and you have covered each and everything of a sewage treatment plant. And hope all the participants who have listened it, they will use this in the form of coming days, so that there will be more finance on the sewage treatment plant. It is the burning thing, and you have explained each and everything very nicely, sir. And hope you will spare time for the future also.
Definitely, sir.
I'm really grateful to all the participants, even all the dignitaries, especially our Rahul sir, because owing to the Rahul sir, we have conducted this seminar, and he is very involved, sir. Rahul sir is our technical head of this entire technical cell, and he is very fond of this thing, sir. And owing to this, we are conducted so many seminars, sir. So, sir, I'm really grateful to Rahul sir also. And in coming days, I often take the assistance from the Rahul sir that similar seminars we will conduct again for the benefits of all the participants. And I request all the participants, still there are any queries, he can send us through the mails so that I can summarize it, and I will send to the all the queries to our yes, sir. And you will get all the queries answers in very short.
Always welcome, sir. Always welcome.
Sir, I have one suggestion. Instead of keeping the webinar for 60 minutes, it should be kept for 120 minutes. Because the topics are such, we should not be incomplete kind of things. Because STP, now today we have discussed, I do not know, maybe after 1 year, again the opportunity will come. It is always better to, in fact, enlighten everything about the pros and cons, and everything about all the participants who are sparing their time. And even I'm thankful to the entire team who has joined, and I take them as Union Bank family, not as that we are the consultant and they are the participant. We are all Union Bank family. We are sitting together and discussing. So I have this request to make it. Thank you very much.
Yes, sir, your
Thanks,
request
sir.
is well
Thanks.
taken, sir. From the next time, we will definitely try to, because just I think 4 or 5 days back in central office, we have organized one webinar on data center, because data center also a very new thing, and it was supposed to be for 1 hour, but it's stretched till 3 hours, because everybody was learning, because even the consultants were learning the data center, so many things are coming. So definitely, sir, and we are really thankful from the Union Bank. We are thankful to the SJ consultant, both of you, for giving us such an in-depth analysis about this whole STP and covering all the aspects in very minutely. With the derivation, Mr. Shah was speaking, I could see he has well done in-depth grassroots level, earthworm view, not bird eye view, earthworm view of the project, and that was very nicely elaborated to us. And thankful from the Union Bank for sparing your time and guiding us in this. And thank you to Ula, Gurgaon, Rajiv ji, Pratik, Neha for organizing all these things, and all my best wishes to keep on organizing all these things. Okay. Thank you.
Thank you, sir. Thank you. Thank you.
Thank you, Rajiv ji. Thank you, Rahul ji. Thank you to the team at Union Learning Academy.
Thank you, sir.